want to present the projects about dataset quality metrics in MLOps pipeline using license plate dataset. And the problem that we want to solve is to find a systematic and automated way to measure dataset quality so that we can continuously improve the model's performance in the MLOps pipeline. For the dataset quality metrics, the dataset role or dataset quality self, as well as annotation quality problems. And there are different ways of solving this problem, but it's not easy to quantify the results. So we first clustered the dataset into 5 different categories, and we used a probabilistic model to give predictions on using Monte Carlo simulation method. Datasets were partitioned into training, validation, and tests in equal proportions. 4 probabilistic models were introduced. So one with a clean dataset, one with a whole dataset with one noisy cluster where intentionally noise was introduced, and the other is trained only with one cluster, and the other is only 2 clusters. And for the accuracy, the results was as expected. For the noisy cluster, we see the performance suffered, the accuracy degraded. And for the unseen data, this was the results of the 1 cluster and the 2 cluster, the models. It was doing very poorly on the data unseen. So this is as expected. For the uncertainty, the normal, the distribution model gave quite a high variability for the number 2 and the number 4 cluster. We see the similar effect as we introduce more noise for certain data. As you can see, we introduce more noise, the model became less certain about the result. But it wasn't always the case, because if the data set itself is limited, what we saw was it seems to be overfitting to that particular data set. So it became more confident regardless of the input. So to make it through the data flywheel, what we propose is we cluster the data sets into different groups, and we recluster, add more clusters, and rebalance based on the model's performance, based on model's confidence measures, and continuously improve the model's performance by collecting and annotating more data for the needed clusters. And how this fits into the overall MLOps pipeline, let Mahavir take over.
So thank you for describing the hypothesis and what we are working. I'll just try to briefly go through the pipeline, what we created. So we chose the license plate recognition dataset. It is a high variability dataset, and state-of-the-art methods have been implemented on this dataset, so we can get a baseline from there. One by one, the first one is to train the model. So for that, we used a YOLO v5. The framework which we used was a PyTorch framework, and we trained it on Colab Pro. For experiment tracking, we used weights and bias. So here are some of the graphs which you can get from their dashboard. You can see the prediction of the car and the license plate and the numbers. For this one, this is another image. Although it should have been predicted as a car, but it is not predicting. I think we need to add more data. That is one of the major reason we need to explore other data sets and bring into our pipeline. Now for serving the whole application, we used Streamlit, and we chose Docker to package the whole thing. For deploying, again, we used Google ecosystem. In terms of that, we used a Google Cloud Run service provided by Google. We gave this option for the user once the inference is done. The user, this is basic dashboard where we deployed, and if you see this is the app which has been deployed. It's working on the internet. Anyone can upload the picture. For example, we are selecting this picture for a motorcycle, and once we upload, it shows the picture we predict, and then we get the inference, and finally we can say, okay, this is correct or not. So we select yes, and that's how the whole thing works. And if we say no, we get this option of writing whatever the incorrect feature was. So that's how we introduce the data flywheel into our pipeline.
we have still some work to do, but as the data flywheel, we have a proof of concept product where it is possible to do have like a systematic and automated way to continuously improve the data set quality and make the model performance better. And more work is needed, but this is a good starting point. And thank you for listening.